Okay, now let's talk about classifications. Classification of the system. We can classify the system by the quantity of the elements of the system. For instance, there exists a system which consists only from one or several elements, and there is consist system which contain many, infinitely many elements. Infinitely many, I don't know. Exist such systems where we have infinitely many elements. For example, if we have abstract system which we do in our brain, and we look at the segment or the line. Okay, the line have infinitely many points, or we imagine we generate some sequence where exists infinitely many elements there, and so on. The next classification is we can divide the system to the static systems and dynamic systems. The static systems have some unchangeable state, or if it changes a little bit. And on the other hand, we have dynamic system. There the state of the system change very frequently and very drastically. Another very interesting classifications of the system that exists the determined system. This is the system's which behavior determined by its internal state and its structure. So if we know the internal state of this system and the structure, they can determine its behavior. This is a determined system. But there is also exists no determined system. If they know state of this system and they know the structure of the system, they can't determine the behavior of the system. Okay, because whereas exists some environment with which this system communicates, and maybe some behaviors of this system depends on the environment of this system. Okay, or maybe we don't know something about this system. We can't go deep enough into this system, into its boundaries. Okay, we have some lack of information. Another very interesting classification is classification when they divide systems by homogeneous system and heterogeneous system. In homogeneous systems, all the elements are very same and they can be interchanged. On the other hand, in the heterogeneous system, all elements are different. They have different function and so on, and so we can change the elements with others in such a systems. For example, if we take a glass of water and look at it as a system, we can take any molecule of this water and exchange it with any other molecule of this water, and it still will be water. But if I take the car and I take as an element its engine, I can change the engine with the car. Another very interesting classification, then they divide the system to discrete system and continuous system. In a discrete system, all the elements have very strong boundaries. We can extract these elements and study them, find their relationships and so on. But in the continuous system, very difficult to extract some element where there is no boundaries. In this way, we can look at this system in terms of processes or in terms of laws, and these processes and laws somehow elements for us, and they study them and so on. Interesting that these two notions, discrete system and concrete system, are relative notions, because one system from different points of view can be in the same way. It can be discrete and concrete. For example, in physics, a wave particle duality, a good example of this. According to degree of organization, they also can classify systems. Where exists a class of poorly organized or diffuse systems, and a class of well-organized systems. So this is the systems, I think, the systems which have very determined laws and how we behave. And that is diffuse system. It's something like I think something like water and so on. And also there is this a class of developing self-organizing system. I think this is something like life forms. Okay. So I think also diffuse system is were related to continuous systems, and these systems we can extract some good elements with good boundaries, or maybe we can extract them, but in this way this will be more like homogeneous systems where many elements which are the same and can be interchanged. Also, we can divide the system by the complexity. We can extract, on the other hand, simple systems, and on the other hand, complex systems. The simple systems have not many number of components. We have not very complex behavior. They have not very different number of relations and so on. And on the other hand, I think complex systems they contain more information about their structure, or many different elements, or the different nature, many different relations, complex behavior, and they are not deterministic and so on. Also, we can classify the systems by the material systems, and they are very physical, and concept systems. These concept systems exist only in our brain. Say hello to Platonic, and all this system can be some mutation of these two things, some joining of these two things. And of course the physical systems consist more from matter and energy, and they can contain information, and they perform some behavior. And on the other hand, in contrast, the conceptual systems live only on our heads. They just abstractions. They only pure information, and they demonstrate not behavior. They demonstrate some meaning. So they are more about meaning than the behavior. Behavior is in the real world, and the meaning in our heads. This is the pure information, or Platonic ideas. Also, we can classify the systems by the isolated, closed, and open system. Isolated system, it just there is no any exchange of this system with its environment, and it doesn't exchange the energy or matter or information. It completely closed the thing inside itself. I don't know, can you find the total isolated system in our world? I think the more closest object to this is a black hole, but black hole it consumes the matter. It doesn't it has any matter on output, but in input it has a matter and energy. I don't know, at least at output it doesn't produce anything. So if there is if such an object exists, I think nobody can know about it, because you can't find it in any way. You can't find this object because there is no exchange with the matter, energy and information. How can you find it? It's absolutely unattainable for you if you outside this system. If you're inside it, okay, you can communicate with it. If you're outside, there is no possible way to do this. And this is isolated system. The next system is closed system. In closed system, there is no exchange of matter, but there is exchange of energy. So I think they can build such a system very close to this definition. I think not very close, because some exchange of matter will be at boundaries anyway. And it's at last is open system, which can exchange the matter, energy, information in both ways, as an input and as an output. Also, by origin or by creation, the artificial, the natural and mixed systems are distinguished. Now let's review some different examples of the systems. For example, we take some complex systems such as a computer system, computer program, very complex. Computer programs now very complex. They have many different types of elements, but at the same way, this system are deterministic, because it has some algorithms and they have strongly defined behavior. On the other hand, there exists such a complex systems, more complex systems, for example, our brain or economy, but with the addition to this property of the complexity, this system has the property of non-determinism. So this is a probabilistic. And now, at the end of this video, I want to come back to the definition of the system. If the system is taken into account the observer, and actually the system exists in the head of the observer. What is a system? It exists in the reality, or is it some function of our brain, of the observer brain? I mean that if we take two different observers to the and they start to observe the same part of the reality, what they will see? Will they see the same system, or this will be the different systems? So this is very relative.